Damini or Karan, like if you are there, please make me the presenter. I think there are some audio issues, so I connected again.
Just give me a minute. Yeah, Rahul, I'll make you the presenter now.
Okay, perfect. Thank you. Okay, guys. So we'll start in another 1 minute. I'm just waiting for all other people to join in. So we'll start at 10:10 exactly. Okay, guys. So there are some unsupervised learning concepts that I want to talk to you today. I went through the syllabus that I was talking to you, right? So आप लोगों ने बोला था hierarchical clustering is something that you want to know. So as part of your syllabus, it's there. So I'll talk about that today. Okay. But in general, I will talk about all the other unsupervised learning models just to have a basic discussion first. Okay. So to start with, unsupervised learning models क्या होते हैं? हम सबको पता है कि unsupervised models वो होते हैं जिनमें कोई target variable नहीं है हमारे पास. अगर target variable नहीं है, as in we don't know कि हमें predict क्या करना है. हमें बस इतना पता है कि हमारे पास कुछ given features हैं. उन features के basis पे हमें कुछ relation निकालना है डेटा में. इसको हम डेटा माइनिंग भी कहते हैं. ओके. तो अनसुपरवाइज लर्निंग एक तरह से डेटा माइनिंग को डायरेक्टली कोरिलेट करता है, जहां आपको हिडन पैटर्न्स निकालने हैं डेटा में से by just looking at the given features that you have. The common way of doing it is using some distance metric, जैसा कि हम KNN में यूज करते थे. तो you will see कि जब सिर्फ फीचर्स ही आपके पास होते हैं तो ज्यादातर आप डिस्टेंस मेट्रिक यूज करके उनके बीच में कोरिलेशन निकालने की कोशिश करते हो. ओके. सो दैट इज लाइक वन ऑफ द वेरी बेसिक वे ऑफ डूइंग इट. So if you look at unsupervised learning is broadly divided into 3 to 4 different areas. To start with, it's clustering. Clustering में क्या होता है कि आपको बोल दिया गया कुछ चीजें आपको दी गई हैं, उन्हें कॉमन ग्रुप्स में डिवाइड करना है. जैसे फॉर एग्जांपल अगर आपको मान लीजिए कुछ इमेजेस दे दी जाती हैं एनिमल्स की, यू विल जस्ट लुक एट द इमेजेस एंड सेग्रीगेट इट. फॉर एग्जांपल आप देखोगे कि मान लो उसमें बर्ड्स भी हैं और उसमें नॉर्मल एनिमल्स भी हैं, उसमें रेप्टाइल्स भी हैं, और मैंने बोला कि इनको 3 ग्रुप्स में डिवाइड कर दो. तो आपको ये नहीं पता है कि रेप्टाइल्स कौन से हैं या फेदर वाले जो हैं उनको बर्ड्स कहते हैं, ऐसा कुछ नहीं है. मान लो यू आर जस्ट अ चाइल्ड, बट यू विल सी कि जिनके पंख हैं वो एक जैसे हैं, तो भाई उनको एक तरफ कर दिया. जो रेप्टिलियन फीचर्स वाले हैं, लाइक दे आर लुकिंग देयर बॉडीज लाइक दैट, तो यू विल put them into another cluster. And similarly there may be some other animals which are walking on the 4 legs, right? So you will put them into a different cluster. And then कुछ images है जो 2 पैरों पे चल रहे हैं कुछ, तो you will put them in one cluster without knowing कि these are humans. Okay. So clustering is all about that. You will take the features and club them. That's it. Okay. So this is about clustering. Then there is another thing which is known as association rule mining. Anyone know what is association rule mining? Can anyone tell me? We are not going to implement all of these, but I want you to be aware about all of these. Guys, what is association rule mining? Have you heard about it? Yes or no? Okay. Association rule देखो एसोसिएशन निकालना किन्हीं दो चीजों के बीच में या दो से ज्यादा चीजों के बीच में, करेक्ट अदिति, राइट, इट्स मार्केट बास्केट एनालिसिस एज इन एसोसिएशन रूल माइनिंग, मतलब कुछ चीजें हैं जिनके बीच में कुछ कोरिलेशन है, एसोसिएशन है, आपको वो पता लगाना है. फॉर एग्जाम्पल, you go to a supermarket and whenever you are buying a toothpaste, you are buying a toothbrush. So there is an association between these two items. Though these items may be independent of each other, as in say there is जब भी beers बिक रही हैं, then there is like say eggs are being sold, for example. But as such इनके features में कोई correlation नहीं है. आप देखोगे तो distance metric भी यूज करके आपको कोई फायदा नहीं होगा यहाँ पे. But there is something which is connecting these two together. Okay, so that's what association rule mining is, where you look at not the features but the data which you already have. मतलब मान लो आप सुपरमार्केट चलाते हो, आपके पास पिछली 50 जो कस्टमर्स का डेटा है, कस्टमर के ट्रांजेक्शन्स का. पहली ट्रांजेक्शन में किसी ने एप्पल एंड ऑरेंजेस खरीदे थे, दूसरी में उसने एप्पल विद बियर खरीदा, फॉर एग्जांपल, लाइक दैट. तो यू हैव सम डेटा एंड यू विल लुक एट दैट डेटा टू सी कि भैया कौन सी चीज किसके साथ बिक रही है. इसी के बेसिस पे पूरी सुपरमार्केट का स्ट्रक्चर डिजाइन कर दिया जाता है कि कौन सी रैक कहाँ रखी जाए. ओके, दैट इज एसोसिएशन रूल माइनिंग. इसमें एक बहुत फेमस एल्गोरिथम होता है यूज. एनी आइडिया विच एल्गोरिथम वी यूज फॉर एसोसिएशन रूल माइनिंग और AR mining? It's known as a priori algorithm. There is a priori algorithm. Okay, it's something again the conditional probability, the prior probability and the posterior probability, like the Bayesian statistics, right? Because it's all about probability. Association rule mining में कोई feature तो है नहीं आपके पास, आपको सिर्फ probability देखनी है, क्या है, किसके साथ क्या बिक रहा है, conditional probability of buying this with that. So that's why the sort of Bayesian conditional probability. Then we have the recommender systems where you see Netflix is recommending you something, Hotstar is recommending you something. You go to Amazon and it's recommend you that people who bought this also bought this, like that. So these are all recommender systems. Then there is one more thing, which is anomaly detection. Anomaly detection as in like outlier detection, right? But it's something more than that. Here you mostly talk about given a system like which should work in a particular way, but suddenly it starts to work in a different way. Similar to you have a lot of transactions and you want to see, oh, suddenly these are fraud transactions. So fraud transactions are actually anomalies in the actual world, right? So anomalies are like outliers, but they have more relevance and they can also be used in the field of fraud detection and all, other than the way you use the classification. Okay, because classification में तो हमारे पास ऑलरेडी मॉडल को ट्रेन करने के तरीके होते हैं, राइट? बट एनोमली डिटेक्शन ऐसा हो गया कि आपके पास ट्रांजेक्शन आ रही हैं और सडनली आपने देखा कि इस ट्रांजेक्शन के जो फीचर्स हैं उनमें कुछ बहुत ज्यादा डिविएशंस हो गए हैं पास्ट ट्रांजेक्शन से. फॉर एग्जांपल किसी कस्टमर की ट्रांजेक्शंस मोस्टली पिछले 1 साल से 1 लाख की होती थी और एकदम से वो मान लो 50 लाख की ट्रांजेक्शन कर रहा है. So that's an anomaly, right? Outlier. So you can definitely use the different outlier detection approaches like standard deviation you have, where you do some fencing and you can do it. But there are more things to it. Yeah. Yeah, Aditi, collaborative filtering is a recommendation system, correct? And then there is dimensionality reduction. Dimensionality reduction itself is like having multiple approaches to do. Can anyone tell me which different approaches they know for dimensionality reduction? Different algorithms for dimensionality reduction? Other than PCA, मैंने आप लोगों को बोला था पिछली क्लास में to read ICA, RCA. Okay, these are some of the other models. But other than PCA, there are more advanced models also. Okay, read about them, which are being used. So we are jumping into the clustering. So clustering, you all know that given the data without a target, okay, target nahi hai aapke paas, sirf data hai, you will do some Euclidean distance or some other distance metric, maybe some other cosine similarity or something, to reach out to a conclusion where you can say that these people belong to same cluster, these people belong to a different cluster, right? That's what clustering is. But you define the number of clusters, not the system, right? You define the best number of clusters based on elbow method or the knee curve or Selauti curve. So if you look at here, okay, so given this data which you have, right, uh, this was grouped into 3 clusters, okay, based on some features, okay, but you don't know कि blue, green या orange क्या signify करता है. So consider it like that कि there is a country in which there is an outbreak of a disease, okay. Now you want to treat patients. So what you will do, you cannot treat everyone, right? You will ask everyone to go through a test, okay, and people will go through a test, and then that test will simply say whether this person is having a good health or he is just suffering from something, right? But you don't know what that thing is. You just know that either his tests that were done, they are of a healthy person or of an average person or of a worst person, as in health wise, okay, good, average or best. You did CBC, complete blood test, for example, okay, but you still don't know whom to treat for that disease. So what you will do, you will divide people into 3 clusters based on this test, for example, okay. This test is nothing but the features, you divide them, and now you, which cluster will you target first? The ones whose CBC based test, like RBC count, WBC count, right, red blood count, white blood count, is coming, say, to be very less than the threshold or very above the threshold, right? You will treat those patients first. So what you will do, you will cluster the people first. So the clustering actually helps you to identify your actual population that you need to target, because otherwise it will be very difficult. तो now doctors क्या कर सकते हैं कि आपने जब 3 cluster में divide कर दिया, तो उसमें से वो randomly कुछ लोग सिलेक्ट कर लेंगे और उनके ऊपर फर्दर ट्रीटमेंट स्टार्ट कर सकते हैं, बट एटलीस्ट दे नो दैट विच पीपल टू टारगेट फर्स्ट. सिमिलरली कॉल सेंटर है, कॉल सेंटर में आपको अपना प्रोडक्ट बेचने के लिए लोगों को कॉल करना है, राइट? You cannot call everyone, right? You take it from, say, yellow pages and you start call everyone. No. What you will do, you will use a clustering algorithm. You will use a clustering algorithm. You will group people based on their age, gender, whatever. And then you have 3 clusters, and then say 1 million लोगों के 3 cluster बन गए. Okay. You have 1 cluster, another cluster, and another cluster of 1 million people now. But now you will ask your call center people to randomly select 100 people from, say, here, 100 from here, and 100 from here, and then ask them to call 100, these 100 only, and then they'll see, okay, these 100 are not giving me any good response, these are also not giving good response, but these people are giving good response. Then they can only focus on this cluster to increase their sale. मान लो कोई इंश्योरेंस पॉलिसी बेचना चाह रहे हैं या कुछ भी, राइट? तो कभी भी जब क्लस्टरिंग होती है, तो क्लस्टरिंग के पीछे देयर इज अ बिगर पर्पस. ओके, यू डोंट वांट टू डू इट जस्ट फॉर द सेक ऑफ इट. व्हाई यू वांट टू डू इट? सो दैट यू कैन target the exact population, whether it's for marketing, whether it's for sales, whether it's for treatment, it can be anything. Okay, so that's when you actually don't have a classification algorithm, but still you want to go ahead with improving your business processes, you use clustering. Okay, there are more things also that you can do, but if you look at this very simple example, like based on the salary and the age, based on the salary and the age, uh, Normally during presentation, these screen sharing shows some problems. Okay, yeah. So now I have enlarged it. So if you look at it, so what I'm trying to show here is based on salary and age, I am just having my population, but I don't have some algorithm which can segregate these two. Okay, I don't have any algorithm that can build a learning line or a learning plane that is there to segregate that. Okay, below this line is this class, above that line is that class. No, but rather what I will do, I will simply start grouping the objects together to create a cluster. Okay, एंड ये जो आपको सर्कल दिख रहे हैं, इन सर्कल की विड्थ या इनका रेडियस जो हम कहें, वो रेडियस जो होते हैं श्रिंक्स भी होते हैं, किसी के एक्सपैंड भी होते हैं. लाइक इट डिपेंड्स कि आपके मैट्रिक्स जो इंटरनल मैट्रिक्स हैं आपने क्या यूज किए हैं, उसके बेसिस पर कितनी आइट्रेशंस आपने बोली हैं. क्लस्टरिंग जब आपने करी होगी तो आइट्रेशंस आर आल्सो वेरी इंपॉर्टेंट टू सी दिस क्लस्टर्स बीइंग क्रिएटेड इन द रियल टाइम. यहाँ आपने जैसे 4 क्लस्टर्स बनाने की कोशिश की है, राइट. इसको आप मल्टी क्लास क्लासिफिकेशन से कंपेयर कर सकते हो, बट उस केस में आपको पता होता है कि चारों क्लस्टर का मतलब क्या है. यहाँ आपको नहीं पता है कि चारों क्लस्टर का मतलब क्या है. There is some similarity, but you don't know what that similarity is. Okay, so when we talk about different types of clustering algorithms, so there are actually too many clustering algorithms available in the market. To start with, there is a centroid based clustering. Okay, we talk about centroid based clustering or partition based clustering. So we start with k means, k median, k medioids, and one is mean shift clustering. These are all centroid based clustering or partition based clustering, where your purpose is to identify a centroid so that everything is around that centroid. You have this centroid, everything is around that centroid, right? So that's what your main purpose is. And k means में k हमें पता है कि is the number of clusters. Means क्या होता है? Can anyone tell me what is the purpose of this means in k means clustering? Guys, what is this means in k means? You have done, right, k means clustering. Okay, a means of all point of the cluster. What that will give you? Yeah, Nishta. Okay. Anyone else? While making clusters, we calculate the mean of all the data points to choose the centroid. Okay. Correct, Aditya, Nishta. Yeah. So k means में what you do is, see, ultimately our purpose is to create clusters and to select the centroid, right? Because clustering का purpose ये centroid identify करना, right? तो वो centroid identify करने के लिए हम क्या algorithm लगा रहे हैं? That's what it is, right? So k is the cluster and means is like you are taking the average of certain values to calculate the centroid, right? But what is the value जिसका आप mean लेते हो यहाँ पर, guys? आपने बोला mean, but mean of what? वो value क्या signify करती है जिसका आप mean ले रहे हो? विपुल देखो, अगर आप सेंट्रॉइड से ही मीन ले रहे हो तो फिर मतलब what is going to be the output of that? Mean of the position of those cluster data points. Okay, Nishtha, but mean of position with respect to what? Is it what Vipul is saying? Guys, I want all of you to answer actually. It's mean distance from the centroid, which Vipul says, but Nishtha, you says it's the position of the with respect to what? You have to be very specific. position of cluster data points with respect to what? Guys, I have one answer from Vipul. Anyone else? With the number of K we have chosen. Okay, no problem. Go mini centroid distance from the other centroid. You guys are giving me mix and match answers actually. Okay. So for that, let's understand what this process is. You are saying K, okay. You are saying means, okay. You are saying means or the average of certain values with respect to something, right? Some are saying centroid, some are saying centroid of that cluster, some are saying centroid of another cluster, okay. Okay, let's see that. But there is another approach which is K median and K medioids. So these are also the same things, but only the statistical formula changes. Instead of mean, either you use median or you use medioid. Medioids is a modified form of mod. There is a separate formula for medioids. I'll talk about this any few of these. So K means, K median, K medioid, you have to be very specific when you're talking about means. It's mean of data points, but with respect to what? The centroid of the same cluster, centroid of the another cluster, or the origin, which is OO, the origin of the feature space. Okay, like you create that feature vector. Okay, but this is about one kind of clustering. Then there is another kind of clustering which is normally hierarchical clustering, and hierarchical clustering is of further two types: top down and bottom up. Okay, we will talk about these two today. Then there is KNN clustering. KNN clustering is like you are using KNN, right? So using the similar approach, you can cluster people. Like using the Euclidean distance, you identify, say, a certain nearest neighbors, and you say, okay, all these belongs to the same cluster. So KNN clustering is not used that much because it's not that good. Plus, I told you, right, KNN itself is a lot of memory based slow model, so we don't use that. There is this thing, fuzzy clustering, which is also available. Fuzzy clustering mostly gives you overlapping clusters, so you should remember this important. Whether a particular clustering is giving you overlapping clusters or non-overlapping clusters. Okay, so K means gives you non-overlapping clusters known as disjoint clusters. Like I asked you to read about discrete mathematics, right? So in the field of discrete mathematics, if these are two sets, right? So these are disjoint sets, means there is nothing common between these. But if this is one set and this is these are joint sets, or they have something in common, right? This part is common. So this is the part of like set theory or discrete mathematics. Okay. So whether your clusters are disjoint clusters or they are joint clusters, like overlapping clusters, so that's one thing. Because in real world, it's really difficult to have disjoint clustering. There may be some people who are on the boundary lines or will fall in both. So boundary line is a very important term. Okay, so either they are on the boundary lines or they fall in both the clusters. So fuzzy clustering is one of that approach. Then there is this DB scan, which is known as density-based clustering. And density-based clustering also gives you overlapping clusters. Okay. So boundary line is those people who are falling near this boundary, either on this or this. Okay. There can be observations which just fall on the boundary line. That's what goes on. Because then those are the people who may belong to the other cluster also. Okay. Okay. So DB scanning is the density based scanning. It's not there in your syllabus, but I'm just telling you it's DB scanning, which is density based spatial clustering. Spatial as in when we talk about geometrical space, 2-dimensional, 3-dimensional space, spatial clustering of applications with noise. Noise again, as in like outliers. If you have too many outliers, right, you can use dB scanning. As in outliers, as in, for example, this point, okay, which does not belong to any cluster, is an outlier. It's like a noise for you. So what will you do for this? No problem, let's consider that as a separate cluster. Okay, that's just on a very high level. So dB scan is a density based इसकी full form है ये, density based spatial clustering for applications with noise. So mostly those applications where there are the points of outliers which does not belong to any clusters, or there is noise, you can use this. But again, it also leads to overlapping clusters. Okay. Then the last one is the mixture models. So there is another field here in machine learning which talk about mixture models. So there is this Gaussian mixture models, okay, where the cost function or the optimization is, you have to there is some expectation function and you have to maximize it. So it's expectation maximization which we do in mixture models or Gaussian mixture models. Okay. So अगर हम बात करें कि हमारी clustering किन parts में divided है, तो normally it's the centroid based clustering or partition based clustering, hierarchical clustering, KNN, fuzzy, dB scan and Gaussian models. Mostly these last three, they give you overlapping clusters, but the above ones, they normally don't give you the overlapping clusters. Okay. Now if you look at this screen, there are few more important technical terms. First is when you create the cluster. For example, I have created this cluster, okay, based on two features. Based on any two features, I am just plotting the data, and you can see the clusters. So here, okay, but now there is something known as intercluster distance and intra-cluster distance. So I hope all of you are aware about it. Intra as in within cluster distance, right? Intra distance. If I talk about any two points, yeah, people. So if there are any 2 points, so what is distance between those 2 points? It can be with respect to centroid, it cannot be with respect to centroid. So don't think that intra-cluster means with respect to centroid. No. Intra-cluster distance is distance of points with respect to each other. That's the intra-cluster distance. And inter is of any given point in, say, or any, ये कोई भी red dot का किसी भी green dot से क्या distance है, that is your intercluster. But computing so many distances is normally very time taking. So what we talk about is we talk about these in terms of centroids. Okay. So for example, if someone say what is intercluster distance, we say okay, it's distance between centroid of this with respect to the centroid of this. But that is not intercluster distance, that is centroid intercluster distance. Okay. Similarly, if I am talking about इन सब रेड पॉइंट्स का इनका जो सेंट्रॉइड है उससे जो डिस्टेंस है वो इंट्राक्लस्टर डिस्टेंस नहीं, सेंट्रॉइड इंट्राक्लस्टर डिस्टेंस कहलाएगा. ओके, सो रिमेंबर दिस स्मॉल थिंग्स हियर. Okay, so here on the screen, yeah, so here on the screen, if you talk about there are some statistical terms using which we tell whether a cluster is good or not. Okay, so कभी भी जब आप clustering करते हो और आपके पास 10-15 cluster बन जाते हैं, can anyone tell me how will you say whether your clustering model is good as compared to another or not? On basis of what? अगर आपको दो क्लस्टर्स कंपेयर करने हैं, हाउ विल यू से विच क्लस्टरिंग मॉडल इज गुड? बिकॉज ऑल क्लस्टर, तुमने पहला क्लस्टरिंग मॉडल बोला मुझे 4 मॉडल बनाकर दे दो, 4 क्लस्टर्स बनाकर दे दो। तुमने दूसरा क्लस्टरिंग एल्गोरिथम चलाया, उसने भी तुम्हें 4 क्लस्टर बनाकर दे दिए, बट विच वन ऑफ दीज टू इज बेटर? या निष्ठा, बट व्हाट इज द स्कोर्स? जैसे आप आरएमएससी एमएससी निकालते हो नॉर्मली रिग्रेशन में या क्लासिफिकेशन में आप करते हो, यहाँ कैसे पता लगाओगे? Yeah, Vipul, definitely. You're correct, Aditi, Vipul. Yeah. So answer is on my screen only, guys. So किसी भी क्लस्टरिंग एल्गोरिथम की गुडनेस ऑफ फिट, मतलब आपका जो भी डेटा है उस डेटा के बेसिस पे उसने जो क्लस्टर बनाया है, how good it is given by WSS, TSS and BSS. Okay, so let's understand that. I hope you already know. If these are two clusters, okay, or let's say this is a third cluster. So each cluster will have its own centroid, right? Each cluster will have its own centroid, right? So now, first of all, within sum of squares is, if you read, is the total distance of the data points from their respective cluster centroids, right? So within SS of this, मतलब इसमें जितने भी डेटा पॉइंट्स हैं उन डेटा पॉइंट्स का डिस्टेंस सेंट्रॉइड से, ओके, that is within sum of squares WSS. You take it for this and for this, and you will add all. So WSS of this cluster, WSS of this cluster, WSS of this cluster, and you will add and you will get the WSS. Okay, the WSS or the total WSS of your model. So it's not total SS, okay? I'm talking about WSS of this plus WSS of this plus WSS of this. That is the total WSS, not total SS, okay? So this is one model. Then you will do it for another model where, say, clusters are quite dense, for example, and their WSS is comparatively lesser, okay? Then what will you say? Higher WSS is better or lesser WSS is better? Guys, higher or lesser WSS is better if you have to compare two clustering models? Guys, can anyone tell me? Yeah. See, WSS क्या है? WSS है कितनी कोहेजन है आपकी, कितने आप एक दूसरे के साथ खड़े हो. WSS is like an error. The bigger the WSS is like the bigger the error, because it's the sum of the distances, right? The bigger the distance means the farther the things are. The lesser the distance, the closer the things are. The closer the things are, the better they are in terms of clustering. Clustering का purpose क्या है? Highly dense clusters, cohesive clusters, right? That's what the purpose of clustering is, right? So remember, WSS is the error. It should be less always. So अगर दो मॉडल्स को कंपेयर करना है तो जिसका WSS लेसर है वो बेटर है. और इवन जब आप एल्बो कर्व भी बनाते हो यहाँ पे, तो एल्बो कर्व भी ऐसे ही बनता है यहाँ पे. WSS is the error. You keep increasing the value of K and WSS should keep decreasing. You create this elbow curve here like this. तो number of K जब बढ़ाते हो तो ये WSS ही होता है जो घटता है यहाँ पे. तो you keep it WSS. Some people says inertia, some said error, right? Error, inertia, whatever. But your error should decrease, WSS. Whether it's about different values of K or whether it's about different models. So एक तो हो गया कि आपने हर एक क्लस्टर का WSS निकाल लिया. That's by centroid से उसका कितना डिस्टेंस है, आपने वो सारे डिस्टेंसेस निकाले, ठीक है? यूक्लिडियन, मैनहट्टन, Mahalanobis, whatever. And based on that, you get the cohesiveness of your cluster. But the another thing is, there is something known as the total SS. What is total SS? It is the total distance of the data points from the global mean of the data. And for a given data set, this is always going to be constant. मतलब clustering चाहे हो या ना हो, जो भी डेटा था, डेटा तो कभी मूव नहीं करता. सी क्लस्टरिंग में कभी भी डेटा मूव नहीं करता, इट्स जस्ट क्लस्टर बाउंड्रीज विच एक्सपैंड्स एंड कोलैप्स, राइट? डेटा तो जहां है वहीं था, तो उस पूरे डेटा का एक ग्लोबल मीन भी जहां होगा शुरुआत में, एंड में भी वहीं रहेगा। ग्लोबल मीन तो कभी भी चेंज होगा नहीं। गुलजार, कोहेसिवनेस मीन्स हाउ क्लोज थिंग्स आर टू ईच अदर, कोहेसिव, राइट? उनकी आपस में कितनी घनिष्ठता है, मित्रता है, दैट्स कोहेसिवनेस। Okay, so remember that the total access of a given data will never change. Okay, any doubt on this, that total access will never change, or you guys are okay with that? Yeah, Gulzar, definitely. So guys, total access of the given data will never change. Is that acceptable to you or not? Yeah, perfect, very good. So total access will never change. Then comes the between SS, WSS. Now what is WSS? WSS is something like कि इन क्लस्टर्स के बीच में कितना डिस्टेंस है भाई, इन क्लस्टर्स के बीच में कितना डिस्टेंस है, इन क्लस्टर्स के बीच में कितना डिस्टेंस है. So then there is WSS. This is the total distance of the various cluster centroids to the global mean of the data. Various cluster centroids to the global mean of the data. So इन क्लस्टर्स के बीच में जो डिस्टेंस है वो दे कैलकुलेट विद रिस्पेक्ट टू, मतलब इनके जो सेंट्रॉइड्स हैं, इनके इंडिविजुअल जो सेंट्रॉइड्स हैं, उनका डिस्टेंस इस ग्लोबल मीन से हम निकालने की कोशिश करते हैं. दैट इज योर WSS. बट उसको आप ऐसा समझ सकते हो कि आखिर आपस में क्लस्टर्स एक दूसरे से कितना दूर है, क्लस्टर्स एक दूसरे से कितना दूर है. एंड BSS बड़ा होना चाहिए या छोटा होना चाहिए? हायर BSS इज बेटर और लोअर? Correct. Higher. Very good. So remember, WSS एक within cluster coherence which would be lesser, and TSS is always constant, and BSS is something which is like clusters के बीच में कितना distance है. And then cluster अपने आप में क्या होता है? Centroid, एक centroid ही cluster को represent करता है. तो centroids का distance कितना है with respect to the global mean of the data. So that's what your BSS is. Now, but in general, we don't talk about WSS, TSS, BSS much. We talk about something known as R square, right? When we say, okay, model की accuracy ज़्यादा से ज़्यादा होनी चाहिए, R square. So there is this formula. R square is the total variance, which is explained by the clustering exercise. मतलब definitely a model is more accurate if it explains more about the data, if it learned more about the data. Okay, it explained more about the data which it has seen, or maybe which it has not seen so far. So the formula for that is BSS by TSS. But let's see how it happens is, I said that BSS should be more, right? So BSS by TSS. So more the BSS, the more the R square. TSS is definitely going to be constant, right? So it's BSS by TSS, higher the better. So that's, you should remember the error terms. So WSS is used as an error term, which should be lesser, and the other two, they are used to give you the accuracy or the R square, which is higher the better. So use WSS as an error, and these two to come to your accuracy, R square, which is BSS by TSS. Okay, so let me just show you this exercise. See, what I'm saying is, ultimately, this point centroid is nothing but mean of all the data, right? That's why it's k-means clustering, right? K-means clustering क्या है? Ultimately your centroid is the mean of all the data points. K-means, so mean of all the data points is your centroid. And mean of what? Mean of definitely the points, जितने भी पॉइंट्स हैं उस क्लस्टर में उनका उस सेंट्रॉइड से क्या डिस्टेंस है वो सारा निकाला, उसका मीन ले लिया, दैट्स इट. बट ये जो मीन्स हैं सेंट्रॉइड्स जो हैं ये तो एक कह सकते हो क्लस्टर सेंट्रॉइड्स हैं, बट देयर इज अ ग्लोबल सेंट्रॉइड. ग्लोबल सेंट्रॉइड एज इन क्लस्टरिंग शुरू होने से पहले जो डेटा था आपके पास उस डेटा का भी अगर मैं एक सेंट्रॉइड निकालता, कैसे? फॉर एग्जांपल अगर ये मेरा रेफरेंस पॉइंट है, अगर ये मेरा रेफरेंस पॉइंट है, हर एक जो ब्लू ऑरेंज या ग्रीन डॉट है उनका यूक्लिडियन डिस्टेंस मैं इससे निकाल सकता हूं, राइट? और उन सारे यूक्लिडियन डिस्टेंसेस का अगर मैं एक एवरेज ले लूं तो मेरे पास कहीं ना कहीं यहां पर एक ग्लोबल सेंट्रॉइड आ जाएगा, राइट? विच इज नथिंग बट यहां से यहां तक का एक वेक्टर. सो आदिति, इज इट क्लियर दैट क्लस्टरिंग से पहले भी जो डेटा था वो इस 2 डायमेंशनल डेटा पे ही पड़ा था, ठीक है? लेकिन हर एक पॉइंट का सेंट्रॉइड इस ओरिजिन से कुछ डिस्टेंस रहा होगा, यूक्लिडियन डिस्टेंस, ओके? उन सारे यूक्लिडियन डिस्टेंसेस का जब आप एक एवरेज ले लो तो वो ग्लोबल मीन आ जाता है, ओके? तो ग्लोबल मीन या डेटा तो हमेशा वही रहता है, कभी भी क्लस्टरिंग में डेटा तो मूव ही नहीं होता. कई बार लोगों को लगता है डेटा मूव होगा, ऐसा तो नहीं है. ये डेटा तो पहले भी जहां था अभी भी वही है, बस हमने क्या किया है कि उनको ग्रुप्स में बांध दिया कि भैया तू इस ग्रुप में बिलोंग करता है, तू इस ग्रुप में, तू इस ग्रुप में, ठीक है? सो रिमेंबर डेटा नेवर मूव्स. देन व्हाट मूव्स? कैन एनीवन टेल मी? ड्यूरिंग क्लस्टरिंग डेटा तो जहां है वहीं रहता है, वो मूव नहीं करता, बट देयर इज वन थिंग विच कीप्स मूविंग. Very good guys, it's the centroid which keeps moving, right? Because if currently this is the centroid and now this another green points become part of this cluster, then this centroid will shift somewhat towards the left because unka bhi contribution isme aa gaya. Centroid is going towards the left, centroids will keep moving. So remember that what the clusters are, what the centroids are, and what the Euclidean distance is calculated with respect to, okay? And then that's what the formula is, okay? So there is one thing which is quite important. Okay, so there is a clustering online graph. So I hope you may be aware about these tools. These are quite fantastic. So let me just show you what I'm trying to achieve here. So there are some online tools, guys, using which you can see how clustering is happening at the back end. If you look at here, these are some of the advanced clusterings that he's trying to show you. Cluster visualization. Okay. Meanwhile, I'm pinging you this link. Please just look at it. I'm looking at another link. आप इसको एक बार जरा थोड़ा ट्राई करके देखो. यहाँ पे क्लस्टर डेटा करके देखो, नंबर ऑफ क्लस्टर्स बढ़ा घटा के देखो, एंड हाउ विल इट बिहेव. ये क्या आउटपुट आ रहा है? ये इनपुट है.
See, this is input. You are selecting the number of clusters. You are saying cluster the data. It's giving you some output. Okay, just try to understand ये क्या है. Meanwhile, I'll show you one more. Nishta, what is this Naphtali Haris? अगर आप लोगों ने ये किया हुआ है तो I think that's good. So yeah, this is what I was looking for. The Stanford thing. Okay, Nishta, I got it. You are talking about this thing, no? Naphtali Haris. No, I use actually this one, Stanford University's link. So guys, let's have a look at this. This will help you remember this always. Given this initial data, given this initial black dots, you don't know how K-means clustering काम कैसे करती है, right? Initially, you don't know what is the clusters and all. Then you will select the number of clusters. Okay, you need 3 clusters, right? So these are the 3 cluster points, right? And find closest centroid, right? So K-means is an iterative method of clustering a set of n points or vectors into k groups or clusters of points and find the closest centroid to each point and group the points that share the same closest centroid. Okay. So this process ran. So what happened here is ये ज़्यादा clustered points हैं. So what happens, how clustering starts it? Whenever you talk about कि मुझे 3 clusters बनाने हैं. So initially 3 data points are selected. Initial, जिसको हम init points कहते हैं, initial points, they are selected. Okay, and now the iterations starts. So there are iterations, first, second, third, fourth. So you say only first iteration. So in the first iteration, all the points they calculate their centroid, Euclidean distance with respect to that particular point. और जिसके वो close हैं, they will all declare that okay, we belong to this particular cluster. But since new points are added, this new centroid will be calculated. So just remember this. सबसे पहले random point select होते हैं in the very first. Okay, then मतलब उन points के पीछे कोई ऐसा logic नहीं है. It's just the random initial points. And then सब उससे Euclidean distance निकालते हैं. जिनके वो close हैं, they will say okay, we are part of this family, we are part of this family, and we are part of say this family. But now, because this is a new family, they will select a new group leader, and now no, this will no more be the centroid, and say centroid will come somewhere here. So centroid shifts will happen. Now since centroid shifts happen, now you again need to check whether now there are more points, because जो अब अंदर है वो तो already इस family का part है. क्या और कोई इस family का part हो सकता है? Because मेरा जो centroid है वो change हो गया है. So then again that cycle will start, iteration cycle. So remember that the number of iterations is very important hyperparameter in K-means clustering. And ये ही चलेंगे. हो सकता है कि 4 iterations के बाद डेटा मूव होना ही बंद हो गया. मैं कहता हूँ डेटा मूव होना बंद हो गया मतलब सेंट्रॉइड मूव होना बंद हो गया. Then iterations will stop then and there, and you have the cluster centroids defined. Okay, So you can just keep playing with these kind of tools. There are even better tools where you can see this data moving also. Here it's a bit fast, but you can just check different data sets here, and you can select the number of centroids, number of clusters or the centroids. हमारे केस में जितने क्लस्टर उतने ही सेंट्रॉइड हमें चाहिए, उतने ही होंगे, बट हो सकता है कि कुछ डेटा ऐसा है जो बहुत ही कम है, लाइक 5-6 रिकॉर्ड्स हैं जो बिल्कुल ही आउटलायर टाइप के हैं, तो वो भी एक क्लस्टर का पार्ट हो सकते हैं. So if you keep running this, like if you keep running this, you can see how my centroids are moving, guys. So this is what I want to show you. So here I let me select lesser because वो coloring अजीब हो जाएगी उसकी. So I'll start find the closest centroid. See, initially मैंने बोला मुझे 4 डेटा पॉइंट चाहिए, तो ये मेरे डेटा पे 4 रैंडम पॉइंट सिलेक्ट हो गए. ठीक है, कोई 4 रैंडम पॉइंट्स. Now my first iteration will run, and this is my first iteration. First iteration, everything becomes part of the orange. My centroids will not move because अभी तो सिर्फ अपने अपना क्लस्टर सबको डिफाइन करना है. बट अब जब मैं अपडेट सेंट्रॉइड कहूंगा तो नाउ सेंट्रॉइड्स विल मूव बिकॉज नया डेटा आ चुका है. So my centroids have moved. But since my centroids have moved, now I have to find new population, new people who can be a part of this. So color have changed. अब आप यहाँ देखो कि डेटा जहां थे वहीं थे, ये आपके डॉट्स जहां हैं वहीं हैं, मूव सिर्फ आपके सेंट्रॉइड हो रहे हैं, और आप चाहोगे कि सेंट्रॉइड बिल्कुल डेंस एरिया के पास आ जाए. जितना सेंटर में होगा सेंट्रॉइड उतना डेंस वो क्लस्टर है, उतना कोहेसिव वो क्लस्टर है, या उतना बेटर वो क्लस्टर है. बट अब मैं जब फर्दर अपडेट्स कर रहा हूं, द मूवमेंट्स आर क्वाइट वेरी माइनर, बट नाउ अब तो मूव भी नहीं हो रहा है. तो दैट मीन्स अब इटरेशंस बढ़ाने का कोई फायदा नहीं है. ओके, फर्दर इफ आई कीप डूइंग द इटरेशंस, माय मॉडल इज नॉट डूइंग एनीथिंग. नीदर इट्स centroid is changing nor the data points are moving out. Okay, out or in. So या तो बाउंड्री किसी की एक्सपैंड करती है या श्रिंक करती है इधर, बट यहाँ पे कोई भी आपका एज एन ओवरलैपिंग नहीं है. इट्स ऑल हैव देयर ओन बाउंड्रीज, एज इन बाउंड्रीज जरी नहीं है, सर्कुलर ही होंगी. इट्स जस्ट दीज आर द बाउंड्रीज, द डेटा बाउंड्रीज दैट आर देयर. दैट्स व्हाट दीज मॉडल्स आर लर्निंग. Okay, so this is how it works. But if you have looked at this one, you have set number of clusters or number of centroids based on this data. So this is your data. ABCD तो बस उसका नाम है, ये उसके 2-dimensional coordinate spaces है. मान लो ये age है और उसका salary है. For example, age and salary like that. Using age and salary, you want to group people into say 2 clusters. Okay, so you will simply do this where this is your labels, these are your vectors or the data points, the feature vector, and cluster IDs you got, right? But ultimately, what is a cluster? A cluster is nothing but a coordinate, XY coordinate, right? A cluster is just identified by its, okay. So Gulzar, any question? Okay, so this is how this particular thing works. Yeah, Gulzar.
सर जैसे अभी आपने क्लस्टर्स के बारे में कहा था ना कि 100 क्लस्टर में से 4 क्लस्टर्स के बाद ही वो सेंट्रॉइड फिक्स्ड हो गया, और उससे थोड़ी देर पहले ये बताया था कि सेंट्रॉइड जो क्लस्टर साथ चेंज होता रहता है. तो मतलब ये तो इन दो स्टेटमेंट्स ये थोड़ा कॉन्ट्राडिक्टरी लग रहा है मुझे.
ओके, गॉट इट. नहीं, मैंने एक्चुअली ये नहीं बोला जो आपने रिपीट किया. मैंने ये बोला, देखो 2 चीज होती है, एक होता है नंबर ऑफ के और एक होता है नंबर ऑफ आइटरेशंस. तो मैं ये बोल रहा हूँ कि नंबर ऑफ के आपने 4 दिया, नंबर ऑफ आइटरेशंस आपने 100 दिया, तो पहली बात तो क्लस्टर तो 4 ही बनेंगे, ठीक है, क्योंकि आपने बोला है भैया मुझे 4 चाहिए, ठीक है, तो 4 क्लस्टर आपको मिल जाएंगे। बट वो 4 क्लस्टर को मिलने के लिए आपका मॉडल कितनी बार रन होगा? 100 बार। मॉडल 100 बार रन करना चाहते हो आप। सो दीज आर टू डिफरेंट थिंग्स। तो मैंने ये बोला था कि n इज इक्वल टू 100 अगर आपने बोला तो मॉडल मतलब 100 बार अपने आप को ट्रेन कर रहा है, उसकी ट्रेनिंग इटरेशंस हैं। जितना ज्यादा आप इटरेशंस करोगे उतना ज्यादा मॉडल अच्छा बनेगा, बट ऐसा जरूरी नहीं है। मैंने बोला क्यों? क्योंकि हो सकता है कि 10 आइटरेशन के बाद ही आपका जो मॉडल है उसके WSS में कोई और गिरावट नहीं आ रही है, मतलब आपकी एरर्स और नहीं घट रही हैं, या फिर आपका जो R² था वो और नहीं बढ़ रहा है, या फिर आपके जो सेंट्रॉइड्स हैं वो मूव नहीं कर रहे हैं, या फिर सेंट्रॉइड तो मूव कर रहे हैं लेकिन कोई और डेटा पॉइंट उस सेंट्रॉइड का पार्ट नहीं बन रहा है। 4 चीजें हो सकती हैं। मैं एक बार दोबारा रिपीट करता हूं। जब हमने k इज इक्वल टू 4 बोला तो 4 क्लस्टर आपको मिलेंगे, ठीक है, लेकिन उन 4 क्लस्टर तक पहुंचने के लिए कितनी आइटरेशंस चलानी है, कितनी साइकिल्स चलानी है? 100। बट ऐसा नहीं होता है कि 100 बोली तो 100 चलेंगी, 100 से कम भी हो सकती है। इट ऑल डिपेंड्स कि आप कन्वर्ज कितनी जल्दी कर जाते हो ग्लोबल मिनिमा तक। इन जनरल अगर हम बात करें तो हो सकता है कि 10 साइकिल के बाद आपका मॉडल कहे कि जो मेरा क्लस्टर बना है दैट इज बेस्ट, लेकिन वो 4 चीजों के बेसिस पे ये होता है। या तो आपकी एरर नहीं घट रही, या आपकी एक्यूरेसी नहीं बढ़ रही, या आपके सेंट्रॉइड्स मूव नहीं हो रहे, या आपके सेंट्रॉइड तो मूव हो रहे हैं लेकिन डेटा पॉइंट्स मूव नहीं हो रहे हैं, मतलब क्लस्टर की बाउंड्रीज एक्सपैंड या श्रिंक नहीं कर रही। 4 चीजें होती हैं। अगर कोई आपसे इंटरव्यू में पूछता है कि ऑन विच क्राइटेरिया और द केसेस अ k-मींस क्लस्टर स्टॉप्स growing or expanding, right? So there are 4 things, remember this. तो मैं गुलजार यहाँ 2 अलग अलग चीजों की बात कर रहा था, ठीक है, लेकिन कुछ ऐसे भी ट्यूनिंग पैरामीटर्स होती हैं जहां आप मांगते 4 हो क्लस्टर लेकिन मिलते आपको 3 या 2 हैं। उनके बारे में मैं अभी नहीं बात कर रहा। अभी हम बहुत ही स्टैंडर्ड अप्रोच की बात कर रहे हैं जहां आप 4 बोल रहे हो आपको 4 मिल रहा है, ठीक है। वो एक तरह से प्रूनिंग क्राइटेरिया मान सकते हो आप, बट दैट्स नॉट ऑलवेज द केस, दैट्स वेरी स्पेशल केस जहां आपके नंबर ऑफ क्लस्टर्स आर लेसर देन व्हाट यू आस्क, वो हो सकता है। ओके, so this is about centroid based clustering, k-means clustering, k-mean, k-median, k-mode, whatever. So let me just try it out. तो सिर्फ आपका स्टैटिस्टिकल पैरामीटर चेंज हो जाता है, के मीन, मीडियन और मोड में काम करने का तरीका सेम ही है, एज इन फाइंड द सेंट्रॉइड, देन फाइंड द मेंबर्स ऑफ दैट क्लस्टर, then find new centroid, new members, then new centroid, new members, keep doing this again and again. Okay. There is one more thing, like when we normally talk about clustering, whichever clustering, whether it's hierarchical or any clustering, right? How can you say this model is good or not? So there are 2 more things. One is known as Dunn's index, and one other is DB score or Davis-Baldwin score. Dunn index is something important. Okay, so I have already shared this notebook. Read about it. So there is this package which automatically do it for you. You can import or download this package and do it. So Dunn index, what it says is the formula for the Dunn index. So before I go into Dunn index, the very first thing was inertia. If you see my screen, right, the very first thing was inertia. It tells us how far the points are within a cluster, WSS, right? WSS or the inertia. So वो एक पूरी अपनी आप में calculation है. So inertia actually calculates the sum of distances of all the points within a cluster from the centroid of that cluster, which is like within sum of squares. You just calculate the distance of everything, that is WSS. and if you calculate the average, you will get the centroid. Okay. And related to inertia, we already aware about TSS, BSS, R square, and all those approaches. The another two metrics that we have is the Dunn index. So Dunn index is a ratio of inter-cluster distance by intra-cluster distance, and it's the minimum by maximum. So it's like if you look here. So what the Dunn index says is, if this is one cluster, this is another cluster. So the inter-cluster distance means this will have some WSS and this will have some WSS, right? So the minimum of the two. So this is W1 and W2. So this one is smaller. So it's like W1, okay, divided by the maximum of the intra-cluster distance. अब यहाँ तो अगर आप देखें तो intra-cluster, sorry, I took it wrong. So it's inter and intra. So intra is within, right? Intra is within. So maximum of intra. So intra is in within cluster distance. So maximum of the two. So it should be W2. And इसके ऊपर जो आएगा, that is minimum of the inter-cluster distance. So where is this? So cluster के बीच में जो distance है, for example, you have inter-cluster distance, as in this is having some centroid, this is having some centroid, and then they say there is a global mean. Global mean, say then they will be calculating this. So for example, say this is M1, this is M2. Okay, so the minimum of the inter-cluster distance, so say whichever is the lesser, say this is lesser, so it's M1 by W2. So that's what the Dunn index is. So Dunn index is the ratio of minimum of the inter-cluster distance and the maximum of the intra-cluster distance. And higher the value, just if you look at this formula, guys, can you tell me the higher the value, the better, or the lesser the value, better? Dunn index. Should it be higher or should it be lesser? अगर आप सिर्फ इस फॉर्मूले को समझने की कोशिश करें. Okay. Guys, anyone else think through and tell me. Dunn index is inter-cluster by intra and minimum by maximum. But if you logically think, it's very easy, very easy. I want you to think that, guys, in interview sometimes you get such formulae which you don't have heard about, and they will ask your interpretation on those formulae, that whether it should be higher the better or lesser the better. So you have to be ready for such kind of unexpected formulas. Okay, so all of you are correct. Definitely Dunn index should be higher the better, because it's saying, see, the ऊपर वाला क्या है, इन clusters के बीच में distance ज्यादा से ज्यादा होना चाहिए, तो जितना ज्यादा ये होगा उतना ज्यादा ये होगा, तो that is good. इंट्रा क्लस्टर डिस्टेंस, राइट, विद इन क्लस्टर डिस्टेंस क्या होना चाहिए, कम से कम, छोटा से छोटा. तो अगर डिनोमिनेटर जितना छोटा होगा, ओवरऑल वैल्यू जो है उतनी बड़ी होगी. तो न्यूमिनेटर मेरा ज्यादा से ज्यादा हो, डिनोमिनेटर मेरा छोटा से छोटा हो. दैट्स व्हाट दिस सिग्निफाई कि WSS लेस से लेस है, और एक तरह से ये आपका विद इन क्लस्टर डिस्टेंस या BSS भी आप कह सकते हो, सॉर्ट ऑफ, बट दैट्स व्हाट इट इज, राइट. But just to tell you, some people also talk about intercluster distance is like एक सेंट्रॉइड से दूसरे सेंट्रॉइड के डिस्टेंस को भी लोग इंटरक्लस्टर डिस्टेंस कहते हैं. Remember that. But BSS is like a special case of it. BSS is like a special case जहां पर सेंट्रॉइड टू सेंट्रॉइड डिस्टेंस ना लेके सेंट्रॉइड टू ग्लोबल मीन ले लिया जाता है. बट इन जनरल अगर कोई लेमैन की टर्म से बात करे इंटरक्लस्टर डिस्टेंस, दैट इज सेंट्रॉइड टू सेंट्रॉइड का डिस्टेंस. बट हाँ, समवन इज टॉकिंग अबाउट अ स्पेशल वन व्हिच इज BSS, देन इट्स अ डिफरेंट थिंग. So the Duns index is in this package, JQM-CVI package. You can pip install this. There is an alternate package also to this, which I'll see if I have. There is another score, which is Davis-Baldwin score, which is reverse, like lesser the better. The minimum value is 0, and the lesser the value, the better it is. You can read about it. This is another score. But I'm coming back to this. So in clustering, there are multiple clustering algorithms, right? K-means, median, mode. So on my screen, what I'm doing from sklearn.cluster, import K-means. Okay, and then I'm doing the K-means clustering here. If you see, inertia or the error should decrease, right? Do anyone know what is mini batch K-means? Any idea what is mini batch K-means? Guys, any idea between difference between the K-means and the mini batch K-means? It's something related to gradient descent and batch gradient descent. If you read about it, gradient descent and batch gradient descent. So क्या idea हो रहा है इससे आपको? What could it be? See, simple. If you have happening in batches, yeah, okay. So see, what's happening here is, जब आप K-means की बात करते हो, तो entire data is taking part in calculating the Euclidean distance and all. Now consider if you have millions of records, and each record is every time calculating its Euclidean distance to the centroids, and say you have more centroids, then it start to become a problem, right? More the observations, more the centroids, then every time every record is calculating its centroid, say Euclidean distance kitna hai uska, ya Manhattan distance. So it takes too much time. So to save that time, we use mini batch K-means. Mini batch K-means does not use entire data. It just uses a sample of the data to do the clustering. 80% or 90% of the data to do the clustering. Okay, so it will be faster, but definitely its accuracy will be a bit compromised because of the speed. So sometimes if you have such kind of requirement where you have millions of records and you want to improve the performance, you can go with mini batch clustering, but knowing that the data which is at the boundary might have the chances of misclustered, not misclassified, misclustered as in going into the wrong cluster. For example, the data which is near these points, like as you see here, that has the chance of maybe belonging to a wrong cluster, but it all depends. If you have millions of records, you can try mini batch clustering as well. Okay, so what I'm trying to show you here is I randomly generated some data. These are two features, and based on that I plotted the data. So initially you don't know whether they belong to one cluster, two cluster, three cluster, but definitely clustering करने से पहले अगर आप अपना डेटा प्लॉट कर लो तो आपको पता लग जाएगा कि हाँ कौन से फीचर्स हैं प्राइमरली जो क्लस्टरिंग में रोल प्ले कर रहे हैं. अगर आप दो के पेयर पे स्कैटर प्लॉट भी बनाते चले जाओगे आपको इजीली पता लग जाएगा. Let me just show you if I have some other data. Let me show you. So क्लस्टरिंग करने से पहले हमेशा ग्राफ बनाओ, क्लस्टरिंग के बाद भी बनाओ. Okay, so what I am having here is, guys, so I'm having a wholesale customers data where मतलब मेरे पास कुछ कस्टमर्स आते हैं मेरे ग्रोसरी स्टोर में और सामान खरीदते हैं, लेकिन अगर मैं इस डेटा को देखूं तो मैं ये नहीं बता सकता कि कौन से कस्टमर जो है वो सिमिलर टाइप के हैं, बिकॉज इट्स वेरी डिफिकल्ट, राइट? मतलब मान लो किसी कस्टमर ने आज तक टोटल मेरे से इतनी ग्रोसरी और इतना मिल्क आइटम्स खरीदे हैं, राइट? तो लेकिन क्या ये कस्टमर सेम ग्रुप को बिलोंग करते हैं? सो दैट अगर कल को मान लो मुझे अपने फ्रोजन प्रोडक्ट की सेल बढ़ानी है, तो मैं सिर्फ उन्हीं लोगों को ऑफर भेजूं या कॉल करूं जो ज्यादा इंटरेस्टेड हैं, राइट? सो दैट कि एटलीस्ट वो लोग ज्यादा से ज्यादा आए, ठीक है? वो जो क्रॉस सेलिंग अप सेलिंग की हम बात करते हैं, क्रॉस सेल अप सेल, ओके? So you have a grocery data and you want to cluster your customers based on the purchases that they have done in the past. There is no target, right? Just you have their data. Channels मतलब होता है ना, आप ऑनलाइन चैनल से खरीद रहे हो, आप फोन करके घर पे सामान मंगाते हो, या आप मेरा स्टोर विजिट करते हो, इसको हम चैनल कहते हैं कि किस चैनल के थ्रू वो ज्यादा से ज्यादा परचेसेस करता है, ठीक है? किस रीजन में वो कस्टमर रहता है, फ्रेश प्रोडक्ट कितने खरीदे, मिल्क कितना खरीदा, ग्रोसरी, फ्रोजन, लाइक दैट, ये मेरे पास उसकी इंफॉर्मेशन है. एंड नाउ आई नीड टू क्लस्टर इट. बट now given all these data, definitely I need it to be numerical first of all, right? Numerical because Euclidean distance and all are numerical formula. Plus scaling is also very important here, remember. So whenever you talk about clustering models which uses mathematical formulae like Euclidean distance, Manhattan distance, anything, you have to first do one-hot encoding type of stuff or label encoding, whatever, and then you have to also scale the data. Otherwise, the data will be biased. Okay, but before all those things, I can simply plot the data. So let me do this: import matplotlib dot pyplot as plt dot scatter, and this is the data, right? So say data dot channel. As a channel won't be that good point to check data dot milk. Like those who are buying more milk, are they buying more fresh items? So it will fail because I have to load this data. Meanwhile, I am pinging you guys. You can try it out. And data, you can take it from my GitHub account under the datasets folder or the unsupervised folder. This file will be there. अगर आप लोगों ने क्लोन करके रखा होगा तो immediately you can read this file if you have cloned my GitHub account. Okay. So now if you look here, right? So गुलजार, मेरा GitHub से आप ये सब नोटबुक ले लो, वहाँ पे डेटा भी मिल जाएगा आपको. हाँ? Okay. So what I am trying to show here is, just by looking at the data, can I say there is some pattern in the data? तो अभी इसको जैसे मैंने आपको पिछली क्लास में बताया था, आप फोर लूप लगा के, मतलब ये काम मैनुअली तो नहीं करोगे ना, फोर लूप लगाओ, उसमें दो के कॉम्बिनेशन पे ये प्लॉट बन जाएगा, एंड यू कैन सी दैट. या फिर आप स्कैटर प्लॉट पूरे डेटा फ्रेम पे भी जब चलाते हो तो वो दो कॉलम लेके बना देता है, बट वो उतना अच्छा विजिबल होता नहीं है. पेयर प्लॉट जिसको हम कहते हैं, पेयर प्लॉट फंक्शन भी होता है. बट अगर आप इस डेटा को देखो तो यहाँ पर आपको कोई क्लस्टर ऐसे बनता हुआ दिख नहीं रहा, सब कुछ एक ही क्लस्टर में जाता हुआ दिख रहा है. दैट मीन्स कि ये दोनों कॉलम अपने आप में मतलब मे नॉट बी दैट गुड टू सिंपली डिफरेंशिएट द डेटा. बट लेट मी चेक कि अगर मैं कोई और कॉलम यहाँ पे डाल दूं, फॉर एग्जाम्पल से ग्रोसरी, एंड इफ आई ट्राई टू सी, स्टिल दिस इज बेटर एज कंपेयर टू प्रीवियस. थोड़ा डेटा और स्कैटर हुआ ऑन अ पर्टिकुलर एक्सिस, बट स्टिल इट्स नॉट दैट differentiable. But क्या say for example अगर कोई फ्रेश आइटम्स खरीद रहा है तो क्या फ्रोजन खरीदेगा वो? तो इफ यू सी more the fresher item people, sorry, here also there is no such pattern if you look at, because इस डेटा का स्केल बहुत छोटा है. 1 second. Okay, but this is the first thing that we have done. Okay, yeah, you should definitely first try to look at your data before you think about any model. Okay, so this is one thing that you will just plot. You will see the data, then you will do the scaling. So I'm doing the standard scaling just from sklearn.pre-processing standard scaler का object बना के the entire data. I just fit transform that data to bring it on a common scale. So remember, you have to handle the nulls, you have to handle the all those stuff, and standard scaler is the best one that you can use. Dot fit transform on your data, and that's it, that's done. But now it's very easy. आप लोगों ने पहले किया होगा. K means clustering. You will start with the number of clusters as 2, and init as in I told you the initialization, the initial centroids, right? What should they be? Should they be random? Should they be based on some strategy? Because if you look here, let me just say this. Okay, ये जो centroids हैं, ये अगर रैंडम है, अगर ये रैंडम है और मान लो सारे सेंट्रॉइड इनिशियली यहां पर ही आ गए, ये चारों यहां नहीं आए, रैंडम है ना, कहीं भी आ सकते हैं, तो जितना रॉन्गली वो प्लेस्ड होंगे उतना ज्यादा आइट्रेशंस लगेंगी, उनको सही जगह तक पहुंचाने में. तो क्या हम रैंडम असाइनमेंट से हैप्पी हैं, या फिर जो सेंट्रॉइड्स हैं, इनिशियल सेंट्रॉइड्स, उनके पीछे भी हमको एक लॉजिक लगाना चाहते हैं? तो दैट ऑल इज बीइंग controlled by that init parameter if you look at. So this init parameter decides the strategy that you want to implement for this thing. K means plus plus is one of the best that you can use. Let me show you the other values. One second. So currently it's running and learning the model. But first of all, the number of clusters, whether you want 2, 3, 4, 5, whatever. Then init as in there can be K means plus plus, there can be random, I was telling, right? So random definitely should not be good. There should be some mathematical intuition behind selecting the initial centroids. That what K means plus plus do, and default is K means plus plus. It's the method of initialization or selecting the C. From your data, you want to select the initial centroids, right? So randomness is not good, right? Because that impacts the convergence. Select initial cluster centroids from K-mean clustering in a smart way to decrease the iterations, right? So if anyone is interested, go through the actual mathematics which is behind it. So you can consider this as a small algorithm. What is the math behind it? You can go through that. And then this is important, max iteration. So max iteration is the maximum number of iterations. It's not exact, it's maximum. It can be less than this also. आपने 300 बोला तो जरूरी नहीं 300 चले, 30 भी चल सकती हैं, ठीक है? So that's what are the hyperparameters which are important. Can anyone tell me what is this n init? Because you have already done this, right? Can anyone tell me what is n init? Guys, any idea what is n init? पढ़ के कुछ आइडिया आ रहा है? Guys, did you use this parameter? Yeah, Karan. What is it, Karan? It's something similar to a very important meta model which we use. What is the purpose? It's related to which of the meta model that we run in regression analytics or classification analytics. There is a meta model or a meta learner. Guys, this is like you have grid search CV, right? So this is like that. Or it's like you are running model 10 times, 10 or rather 10, say they have different models to see which of them is better. So n in it is 10 means you are running 10 different k-means models here to see which one is better. It's like grid search CV. Okay, 10 different models you are trying. But then the question is, what is the different value which these 10 models are trying? Can anyone tell me? Absolutely, Karan. Absolutely correct. So I told you, right? I told you this thing. The better the performance of your model depends on these initial points. So if say you are selecting it randomly, you can select it randomly any different way. बहुत सारे तरीके से select कर सकते हो, right? So it will select 10 different random combinations of those centroids to give you the best model. So that's what the n in it is. Okay. वर्बोस ट्रू कर देना, रैंडम स्टेट भी यूज कर लेना. Okay, so if you look at here, what's happening, guys, very simple. If you look here, what's happening is initially the first model will run, and first model will run 300 times because my iterations is 300, right? My max iterations is 300. So my model will run 300 times, but as I told you, it just ran at 15th point because convergence happened here. The strict convergence happens here. Inertia was decreasing, but after this point, see, बहुत ही minimal decrease, and then it further didn't decreased. But now the another model will start with another set of random centroids, and again you will get the convergence. It will keep converging. So कुछ models तो 2 iterations के बाद ही converge हो गए, right? So it ran and then it trained the best model out of these. Okay, and if you look कि भैया उसने 10 मॉडल चलाए, अब फाइनली जो भी बेस्ट मॉडल उसने सिलेक्ट किया है उसका इनर्शिया कितना है. So the best model that is selected is having an inertia of this much. Okay, 3855. जैसे इसका देखो, इसका क्या है, डेसिमल प्लेसेस में 3873, इसका 3855. So the best model that it selected out of all these is which converged to the least inertia or the least WSS. Okay, the least WSS, the one that it converges to. So that's one thing, how you can simply have your model done. But now once you have fitted the data, the next thing that comes is prediction. So how will you predict, right? So for example, in future, if you get new data, so you have to definitely scale it to the same level, and then after scaling you will pass that data in the predict function. Predict function will simply predict what? Can anyone tell me? K-means का predict function मुझे क्या output देगा? अगर मैं predict करना चाहूंगा तो मुझे क्या output निकलेगा K-means के predict से? Okay, yeah, very good, centroid, right? So if you look at this, guys, what I'm trying to print is cluster centers, right? I'm just trying to print you the centroids. So this is the first centroid, first cluster. This is the second cluster or the second centroid. And can anyone tell me why so many values? Centroid तो सिर्फ x और y कोऑर्डिनेट पे होना चाहिए. ये 1 2 3 4 5 6 7 8 8 वैल्यूज क्यों आ रही है मेरे दोनों सेंट्रॉइड्स के अंदर? नहीं, ये पहला क्लस्टर है, ये दूसरा क्लस्टर है. क्लस्टर तो 2 ही बने हैं, लेकिन हर एक क्लस्टर में ये 8 कोऑर्डिनेट्स क्यों हैं? ये 8 वैल्यूज क्या सिग्निफाई करती हैं यहाँ पे? Guys, please think. So far, no one has given me the right answer. Okay. No. Nishtha, you are see. These are 2 centroids, but what these 8 points represents? These 8 points within this. Vipul is correct. No, guys. Okay. So Vipul is correct. These are the 8 features actually. This is corresponding to the 8 features that my data have, right? So this is the 8-dimensional space. If I talk about, this is the 8 feature values or the 8-dimensional space of the centroid. मान लो ये एज को रिप्रेजेंट कर रहा है, ये जेंडर को, ये उसकी सैलरी को, ये किसी को. तो these are nothing like these are not for different iterations, these are not clusters, these are not distances. No, nothing. These are just for the 8 features. We have certain values, right? And if you say these are the distances for 8 features from the origin, okay, then you are right. So as in, if this is a 2-dimensional space, अगर मैं पहले और दूसरे फीचर की बात करूं, तो ये सेंट्रॉइड अगर मेरा ये ओरिजिन है, तो यहां पर x1 is this, x2 is this. So this is like x1 x2, but ये 2-dimensional space है, right? Multi-dimensional space अगर हो जाएगा, ये अगर यहाँ से बाहर को निकलने की कोशिश करेगा, मान लो on this axis, तो then this is the third feature having distance from origin. It keeps evolving like that. Okay. So ultimately अगर आपने मुझे क्लस्टर सेंट्रॉइड्स दे दिए, मुझे ऊपर के पूरे डेटा की कोई जरूरत नहीं है. मैं सीधा इससे खुद से यूक्लिडियन डिस्टेंस निकाल के बता सकता हूँ. कोई भी फ्यूचर में अगर नया रिकॉर्ड आया, अगर मुझे उसकी वैल्यू पता है कि उसका एज इतनी है, एज जेंडर सब पता है, तो मैं इन वैल्यूज को यूज करके यूक्लिडियन डिस्टेंस निकाल लूंगा ना. गाइस वो तो सिंपल है ना, राइट? कि अगर मुझे कल को आप एक नया x1 x2 देते हो, तो मैं क्या करूंगा, x1 माइनस x2 प्लस, मतलब सॉरी, this x1 minus this value plus x2 minus this वाला वैल्यू प्लस x3 minus this value प्लस करता रहूंगा, मैनहट्टन डिस्टेंस निकल जाएगा. अगर मैं स्क्वायर करता जाऊंगा तो यूक्लिडियन डिस्टेंस. तो आई नीड ओनली सेंट्रॉइड्स, दैट्स इट. ओके. Here I am just trying to plot the elbow curve, inertia versus number of clusters, like if I try multiple values of clusters, how my model should work. So if I look at k means n jobs minus 1, मतलब जितने भी CPU कोर्स हैं सब यूज कर लो. नंबर ऑफ क्लस्टर्स में हार्ड कोड नहीं कर रहा, तो मैंने एक फॉर लूप चलाया गाइस, फॉर लूप. और मैं कोई मुझे बता सकते हैं कितने मैंने k की वैल्यू कहां से कहां तक ली है? How many different values of k I am trying? Range 1 to 20 gives you what, guys? Range 1 to 20 gives you what? For I in this, if you simply do print I 1 से लेके 19 तक, okay? See the starting value, guys. For I in range 1 to 20, print I. So it starts from this, and this is exclusive. So from 1 to 19, right? So from 1 till 19 it will run. But ideally, some of the models, they will not allow you to pass the value of k as 1. They may fail. So you have to pass minimum k as 2 and maximum anything. It depends. If you get an error, that you should not do it, right? So can anyone tell me what is the limit on minimum and maximum value for clusters? So minimum value तो ideally should be greater than equal to 2, right? 2 या 2 से ज्यादा cluster. ठीक है, 0 या 1 तो is like error. Max value पे क्या restriction है? How many maximum clusters can you have? So ideally, the number of records that you have, right? That many clusters you have. But that's the worst model. जितने records है उतने cluster, मतलब हर एक cluster में सिर्फ एक record, right? So you should not do that. Okay. It's number of records this time, not number of features. Because if you look at this thing, right? Let me show you this. Yeah. Here I have 4 records, right? 4 records. So let me say 4. I get 0, 1, 2, 3. 4 cluster मांगे मैंने दे दिया उसने. मैं कह रहा हूँ नहीं मुझे 5 दे दे भाई. Fail. No result. Too many clusters or too few different instances. Try changing K. Okay, remember another interview question. So the maximum number of clusters that you can have is equal to the number of records you have. Okay. But that's not good. Okay. And ideally, number of clusters you select based on this thing, which I am just showing you here. So if you look at this graph, so somewhere here is the best value, or somewhere here. So 5, maybe a bit of optimal value here. 5 or 6 is the optimal value. You can select that. ओके तो यहाँ पर जस्ट मैंने कुकड अप डेटा डाला. तो जो भी अगर फ्यूचर में आपको डेटा मिले जिस पे आपको प्रिडिक्शन करना है तो आपको पहले उसको स्केल करना पड़ेगा, क्योंकि जो मॉडल ट्रेन हुआ है वो स्केल्ड डेटा पे ट्रेन हुआ है, राइट? तो जितनी भी ईडीए आप टेस्ट ट्रेन डेटा पे करते हो वो आपको टेस्ट डेटा पे करनी पड़ती है या फ्यूचर डेटा पे भी करनी पड़ती है बिफोर डूइंग प्रिडिक्शन. तो मैंने यहाँ पे 2 रिकॉर्ड्स के लिए मांगा कि भाई आप किस क्लस्टर को बिलोंग करते हो. तो ये 0th क्लस्टर को बिलोंग करता है एंड ये 2nd क्लस्टर को बिलोंग करता है. Okay, so that's how it is. बाकी यहाँ तो मैंने क्या किया है, बस जो भी इनपुट डेटा था उसके साथ उसके क्लस्टर्स को ऐड कर दिया. नथिंग एल्स, जस्ट टू सी. दिस इज इम्पोर्टेंट. फॉर एग्जाम्पल आफ्टर क्लस्टरिंग यू वांट टू सी कि किस क्लस्टर में कितने रिकॉर्ड्स गए हैं. तो वैल्यू काउंट से आप देख सकते हो कि there is a particular cluster in which very less records went, so that means still it's a chance of converging it to another cluster. So you can decrease the number of clusters and try it again because they may be on the boundary, and then because you selected 5 clusters to wo alag chale gaye. So here if you look at here, I talked about 2 things, done index and the Davis-Baldwin score. So there are these packages using which you can do it. So these are the things from sklearn.metrics. You have Davis-Baldwin score. You have to pass on your scale data and the prediction also, as in what is the target that you are predicting, right? The cluster to which it belongs. So your prediction is the clusters. Okay, and this is your data and this is your output. You pass it and it will tell you. So the lesser the better. And for doing the done index you have to install this package JQAM CVI. Okay, make sure you install this package to do this. Okay, so now once we are done with this kind of clustering, K means clustering, the another one that that's there is hierarchical clustering. So what is hierarchical clustering, guys? Hierarchy. So if you look at this thing, like you have a decision tree, right? So it's something like building a decision tree, but it's not exactly a decision tree. This is something else. Let's see. Yeah. So when we talk about hierarchical clustering is of a hierarchical mode. Hierarchy क्या होती है? एक decision tree क्या होता है? It's like parent then child, right? You keep building a tree. So that's like an hierarchy. So similarly, in the case of hierarchical clustering, it's not like a centroid based clustering where you are doing all those calculations, right? So here you don't start with the initial clusters or you start with the centroid calculation and all. You don't do that. But you still use distance metric. Distance metric is still used, but in a different way. So like Euclidean and all, they are still used. So hierarchical clustering builds a tree, but these trees are known as dendrograms. Okay, dendrograms. That's one thing. But these trees can be built in two ways, top down and bottom up. What is that? Top down means you're building from top to bottom. Okay. And doing that top to bottom is known as divisive clustering. Divisive as in, you remember, divide, just divide the things. Iski spelling I'll tell you. Divisive, it's divide. Okay, you start with everything as part of one cluster. मान लो आपके पास 100 records हैं, observations है, you will say everything is one cluster. Then based on their features, you will split them into, say, 2 clusters. Say 10 records came here, 90 came here, based on some internal feature comparison. Then you further do the feature comparisons internally, uses a distance metric, and then you will further think that, okay, there are observations which are different from each other and can further be segregated. So you will segregate it. And you will keep doing that until you reach to a place where you have total 100 nodes. Because you have 100 records, right? So 100 records in one cluster will keep dividing until you have 100 leaves where each leaf is having 1 record. So it's like building a deep tree. Okay. But the problem is, that's not what I want. I'll say I want 4 clusters. Okay. If I say I want 4 clusters, then automatically pruning will happen. It will start from here, right? It will go up till here. So at this place, only 1 cluster was there. At this level, how many clusters are there, guys? 2 or 3? Can anyone tell me? At this level, there was 1 cluster. At this level, is split it into 2. So I have like 2 nodes here. So at this level, how many clusters I have? 2 or 3? Yeah, it's 2. Because पिछले लेवल का तो कोई पर्पस ही नहीं रह जाता ना यहाँ पे. तो अगर मैं इस लेवल पे रुक जाऊं तो टोटल 2 क्लस्टर ही मिलते हैं मुझे. बट अगर मैं इस लेवल पे आ जाऊं तो 4 क्लस्टर्स मिलते हैं मेरे को, राइट? So this is nothing but like a pruning criteria. In hierarchical clustering, a tree or a dendrogram is being built and it keep building unless it gets a prune criteria, which is either number of clusters or it may be some other hyperparameters which can also prune it. We will talk about that. But yeah, so dendrograms does not keep growing till the 100 nodes. They don't do it. There are a lot of criteria which stop them from splitting. Okay. One of them is even the errors, the something like WSS, right? So if your errors are not decreasing after a particular split, it will not do it. For example, after this level, when you came at this, it must have checked for some reductions in the errors or some thresholds. We actually set some thresholds. If that thresholds are not met, that pruning will not happen. Okay, I'll explain you, Vipul. I'm just telling you abhi to the main thing. We will go into the distance metric thing. So each node is true only. Yeah, Aditi. So each node here we are talking about currently. This is like a binary split that happens. Okay. So this is known as your dendrogram. It does not. It's not actually a tree. It's a bit different from that, but just to correlate, it's like a tree. The another approach is bottom up. Okay. So the bottom up approach is reverse, which is agglomerative. Agglomerative approach says you start with too many observations, like say you have 100 records, all 100 records will be leaf nodes, and you keep clubbing them into groups. You will keep clubbing them into the groups, again based on some distance metric. There is a distance metric that compares their features, right? So for example, there was this 5 records, okay, and these 3, they become a part of one group, these 3, whereas these 2 become part of one group because of the Euclidean distance that you calculate. So these 2 might be closer to each other as compared to the other ones. Okay, so the model will group them. But again the point is, अभी यहाँ पे कितने ग्रुप्स थे मेरे पास? मान लो यहाँ पे मेरे पास 5 ग्रुप्स थे क्योंकि 5 रिकॉर्ड थे. Further it went up, but it will club how many? It will club only 2. So it will club these 2. ये वाला भी बेचारा रह गया, ठीक है, for example. Then at the next level it will club this with this. So your clusters will keep growing. Initially it was 5, then ये दोनों एक साथ जुड़ गए based on certain features. ये दोनों एक साथ, ये अभी रह गया, ठीक है. At this level ये ऐसे कैसे आ गया? तो 3 clusters हो गए यहाँ पे. Then I further go up, ये वाला इसमें merge हो गया, ये वाला ग्रुप अभी भी वैसे ही रहा, तो मेरे पास 2 clusters बन जाएंगे यहाँ पे. So it is like bottom up. But the problem with bottom up is it is too much time consuming if we have too many observations. अगर आपके पास millions of records हैं तो top down is better as compared to bottom up. Okay, because you will start with too many leaf nodes and then you will compare them with each other, and then you will keep grouping them as per the hierarchy. So remember that which one is better in which case. Like if you have too much data, go with top down instead of bottom up, because then you have that many leaf nodes if you go with bottom up, जितने observations हैं. और यहाँ पर भी यही होता है, ये कब तक ऊपर बढ़ता रहेगा, बिकॉज फाइनली जब ये ऊपर जाएगा वो एक सिंगल लेवल पे सबको क्लस्टर कर देगा, जब तक कि अगेन आपकी एरर्स जो है या तो वो डिक्रीज होती चली जा रही हैं या आपका प्रूनिंग क्राइटेरिया आ गया है. इट विल कीप डूइंग दैट. सो दैट्स व्हाट योर हायरार्किकल क्लस्टरिंग इज. लेट्स सी इट इन डिटेल. Okay. So first of all, this is how the dendrograms looks like. This is how they look like, not like a normal tree. Just is the representation. So as I told you, top down is divisive and bottom up is agglomerative. Okay. इसको याद रखने का सिंपल तरीका है, जब आप एग्रीगेट करते हो चीजों को, इकट्ठा करते हो तो नीचे से ऊपर जाते हो, और जब आप डिवाइड करते हो तो ऊपर से नीचे जाते हो. कीप डिवाइडिंग डिवाइडिंग डिवाइडिंग. तो रिमेंबर लाइक दैट. Top down and bottom up, divisive and agglomerative. So this is what it's showing you. That's how your clustering looks like. So for example, if you start here, in case of you have so many records. So as I told you, at every step it's like 2, it's binary, right? Either split in 2 or merge 2. Okay, so it's always binary. So you will see that initially the two features which are highly correlated were these two. Out of the entire ones, these two, so they were grouped. These were not very correlated, they didn't grouped, and then these were correlated, they were grouped. Okay, then on the next iteration it further happened. Okay, यहाँ पर आप एक चीज ध्यान रखें, अगर तो ये आपका पहला, मैं आपको बता रहा हूँ यहाँ पे बॉटम अप, ठीक है, नॉट टॉप डाउन, आई एम टॉकिंग अबाउट बॉटम अप एग्लोमरेटिव. तो एट द फर्स्ट लेवल तो सिर्फ ये दो ही आपस में कोरिलेटेड हुए, 7 and 8, बट नेक्स्ट लेवल पे 2 और 3 and 6 was joining this cluster. मतलब इस क्लस्टर में जो भी मान लो फीचर शुरू में यूज किया, इसकी एज कुछ होगी, इसकी एज कुछ होगी, इन तीनों की एज के बेसिस पे वो सिमिलर नहीं थे, ये दोनों की एज तो बराबर ऑलमोस्ट सिमिलर थी, लेकिन जब इनका कंबाइंड क्लस्टर का एवरेज लेके जो एज आई, उस एज को जब इसकी एज से कंपेयर किया गया तो वो इसके क्लोज आ गया, तो ये भी इसमें घुस गया. मान लो ये 30 साल का या 32 साल का था, देन टुक सम एवरेज एंड देन दैट एवरेज इज कमिंग टू दिस. ये सिर्फ एक फीचर की बात नहीं है, और भी बहुत सारे फीचर्स कंट्रीब्यूट करेंगे. देन इट बिकेम कोरिलेटेड टू दिस एग्रीगेटेड ग्रुप, जो भी उसका एक मीन ऑफ द फीचर्स था, एंड एट दिस लेवल ये दोनों भी आपस में ग्रुप हो गए. तो सिमिलरली इट इज कीपिंग टू ग्रो बेस्ड ऑन द डिस्टेंस मेट्रिक और द लिंकेज क्राइटेरिया. So there is something known as linkage criteria here. Distance metric is a secondary thing here. The primary thing here is the linkage criteria. We'll talk about that. So they'll keep linking unless they reach either to the top or a pruning criteria will happen. So that's what here the linkage will happen. Linkage criteria will be given, and then the distance metric will be used internally. Okay. Some people also represent this horizontally, just for your knowledge. Some people don't talk about it vertically, they talk about it horizontally, but it's same thing. It's like with each step that you are taking, like initially step 0, everything was leaf. Step 1, 2, 3, 4, you keep, with every step you keep aggregating them, and it became agglomerative. So agglomerative is used quite often, but again, if the data is too much, you should not use it in millions. Whereas in the case of divisive, this it's ulta. Step 0, you have the root everything, and then step 1, 2, 3, 4, you keep going like this. Okay. Now let's see the hyperparameters here. So I'm just creating a copy. Okay. So like k-means and all the others. Guys, just open the site packages and try to check all the clustering algorithms which are available. Here it's not showing the drop down right now. Okay, so if you come inside this within the sklearn, there is this thing. We have clustering algorithms, right? Okay, so if you look here in the clustering algorithms, we have k-means, we have k-median, k-mode, everything. Mean shift also, the mean shift algorithm. Then we have db-scan and agglomerative. Similarly, you will be having the other ones also. Okay, hierarchical clustering if you see. So just make sure you keep looking at this. Let's open any one of this hierarchical clustering one. So if you look at hierarchical clustering here, it's not giving us the divisive by default, though that can be done. It's giving us agglomerative. So agglomerative clustering it's talking about. So let's talk about agglomerative, which is bottom up. Yeah. So bottom up, as the name suggests, it works in a bottom to up fashion, right? It keeps combining them. So there is something known as heap concept. Can anyone tell me difference between a okay, what is a heap in terms of data structure? Any idea what is a heap? Guys, what is a heap? Heap, a heap. Any idea what is a heap? What's a stack? Any idea what's a stack? Okay. No. In terms of data structures, do you know difference between a stack and a queue? Guys, anyone? Stack versus queue? Okay. What's the difference between stack and queue? Anyone? Okay, which one is first in, first out? Stack or queue? Which one is FIFO? Which one is FIFO and which one is LIFO, guys? Which one is FIFO? Which one is LIFO? Hello. Okay. So Q is a FIFO and LIFO is a stack. Okay. Good. Guys, yeah, remember that. And heap is like another data structure in which, as someone was saying, it's like pile of data. But normally, when we talk about storing the objects in memory, they are stored in heap memory. So there is a stack memory and a heap memory. When we talk about storing the objects or variables, the variables that you create, right? Like x is equal to 2, x is equal to 20, or you create objects of the models. They are stored in memory, system memory, in the form of objects and variables. So there are two kinds of memory, heap memory and stack memory. Okay, so just read about it. If you have any doubt, I will tell tomorrow. But whenever you are doing any programming, what is this? Yeah, for example, whenever you are creating this is a object, right? Or you are assigning a variable, a value, say 22. So this is a variable. They are stored somewhere in memory. So memory storage is handled in two ways: heap memory and stack memory. What is the purpose of these two? Understand it. Okay. But if you look at a tree is like a heap kind of a structure. If you look at a tree, so this kind of structures are heap based structure where you keep accumulating them at each and every step and you keep like growing. Okay, so this is how a heap kind of a structures looks like. A hierarchical structure, definitely tree based structure, hierarchical structure. So that's how heap is organized. So read about it. Okay, So we have agglomerative clustering here, if you see. So we are using hierarchical clustering, and within hierarchical we are using agglomerative clustering. Now we will create an object of this, and this object will be stored in memory in the form of heap memory or stack memory, like that. But now if you look here, what it is doing is recursively merging the pair, okay, 2 by 2, every time 2 pair of clusters that minimally increases a given linkage distance. So there is some linkage criteria which uses some distance metric, and minimally increasing a given linkage distance. So we will talk about that. So let's start with this first. So number of clusters, right? So number of clusters, as we know, how many levels we want to go up, that's the number of clusters. So if you start from the bottom, so the number of clusters will decide कि आप कितने further level तक आप जाओगे. अब यहाँ ये further मान लो कोई join नहीं हुआ, but at this level it joined with this. So at this level there were 4 clusters. At this level, can anyone tell me how many clusters? And at this level how many clusters? First tell me इस level पे कितने clusters हैं? यहाँ पे 4 हैं. Looking at this dendrogram, if given in an interview, sometimes in MCQs they give you in written exams. So at this level, how many clusters can you see at this level? Okay, perfect. So one is this, one is definitely this. At this level, another was this, and another was this, 3. But then this was combined with this, became 1, and this was like again. So at this level there were 2. Okay, so that was your number of clusters. But now affinity. So affinity is actually the metric here that we use to calculate. So the like Euclidean distance and all, right? So here we said affinity. So affinity by default is like Euclidean. There are another ones like Manhattan or cosine if data is categorical. These 3 are quite important: Euclidean, Manhattan, and cosine. Yeah. So then another one is this linkage. So the linkage is what actually decide how mathematically the model will be working. So I'll talk about this. Linkage is like word, complete, average, and single. And this further internally uses the statistical criteria to either increase a particular value or decrease a value. Like word minimizes the variance of the clusters being merged. So definitely the clusters which are cohesive have least variance. That's one thing. It minimizes the variance of the clusters. So similarly, there are other. I'll talk about this in detail. Yeah, but this is another one, which is threshold distance. So on the Euclidean distance or that value which is getting decreased, right? You put a threshold. So if you put a threshold, that's where I was telling you, right? कि आप लोगों ने, अगर आप लोगों ने बोला मुझे 4 क्लस्टर चाहिए, सॉरी आपने बोला मुझे 2 क्लस्टर चाहिए, it keep growing here, and then further, for example, it goes here, right? So at this level, at this particular level, you have 2 clusters at this level, not at this level. At this level, you have 3 clusters, right? आपने 2 cluster मांगे थे, तो normally model will give you two clusters. But if this threshold distance is like when you move to this, when you go to this level, and you see when the clusters, this cluster and this cluster, they were merged. After merging, did I get a reduction which was as per the threshold? If yes, okay, keep it. It's something like how decision trees, they grow based on cost complexity parameter. Otherwise, you will not do that merge. Means if my threshold was, say, let's take that value, decreasing value is better, for example. So here it's 3 and here it's 2. Very good. 3, 2. So 2 is say lesser error. So you are happy. But you have passed on the threshold as 2.5. If you have passed on the threshold as 2.5, this split will not happen. This merge will not happen. Here it's a merge, right? Agglomerative is a merge, divisive is a split. So this merge will not happen because your threshold was 2.5, but the value you are getting is 2. But if this would have been 2.7, this would have happened. So that's where तुमने मांगे हैं 4 क्लस्टर बट तुम्हें मिल रहे हैं 3, या तुमने मांगे हैं 4 तुम्हें मिल रहे हैं 5. These are all dependent on the thresholds also. Okay, so we will play these values and see how they will impact it. I'll tell you, Aditi. For that, we have to talk about this linkage criteria, because that's where we have to set the threshold, whether the threshold is for variance, whether the threshold is for the maximum distance. Okay, so if threshold is say 4 and if you say threshold as a distance is 4, okay, but after split you are getting 4.5, okay, and before that it was 5, so definitely your distances are decreasing, so this split should happen. But say I'm saying it's 4 and a value which is say greater than 4 is only allowed. A value which is lesser than 4, I don't want to go up till that level. मैं इतना ज़्यादा split merge करना ही नहीं चाहता. I don't want to merge so much. I want कि मैं इतनी value पे happy हूँ. ठीक है? So we'll see that. So your threshold values depends on the linkage criteria that you are selecting. Okay. So guys, I will be doing that tomorrow because I have to go somewhere today. But before I end the class, I want to tell you about this PPT. I'll take 15 minutes, and then tomorrow we will start with the implementation of the hierarchical clustering and DB scan clustering also. But that we will do tomorrow. So I'll just take 5-10 minutes to go through this PPT. Okay. So far we talked about k-means clustering and then the hierarchical clustering. Hierarchical clustering is of 2 types, but how they work, whether they divide or they merge, it depends on some linkage criteria which uses some matrix internally, either a distance metric or a variance metric, and on that distance metric or a variance metric we can set some thresholds कि भाई इसके ऊपर या इसके नीचे की वैल्यू ही मुझे डिसाइड करेगी कि मेरा merge या division होगा या नहीं. Okay, that's one thing. After that, there are other clusterings also, like density based or Gaussian mixture models, which is different. Okay, so we will implement that tomorrow. Now coming to association rule mining. So association rule mining, I just want you to be aware about it, how these works. So association rule mining is something like this. So how association rule mining works is, you have transaction IDs. Transactions as in एक कस्टमर आया कुछ खरीद के गया, दूसरा कस्टमर आया कुछ खरीद के गया, तीसरा आया कुछ खरीद के गया, इसने क्या खरीदा, इसने क्या क्या खरीदा, इसने क्या क्या खरीदा, like that. But now when you look at this data, you want to see the correlation or association कि ब्रेड के साथ क्या बिक रहा है, मिल्क के साथ ज्यादातर क्या बिक रहा है. फॉर एग्जाम्पल इस केस में अगर मैं ये देखना चाहूँ ब्रेड और मिल्क के बीच में कोरिलेशन कितना है, तो ब्रेड और मिल्क यहाँ पे भी बिक रहा है 1, 2 and 3. So total there are 3 records or transactions which support. So I have a support of 3 for this combination. Okay. So association rule mining क्या करती है, वो आपके ट्रांजेक्शन्स सेल्स डेटा को देखती है, और सेल्स डेटा में ये देखती है कि आप किस चीज में इंटरेस्टेड हो। मान लो आप ब्रेड और मिल्क में इंटरेस्टेड हो, इनके कॉम्बिनेशन में, ब्रेड एंड मिल्क, then your support is of 3. So you will create this kind of a chart. So this chart is telling you what? So when you are saying bread and milk means 2 items, right? So item 1, item 2. So it's an item set. So this is an item set whose length is 2. Item set of 2 items. Item set of 3 items. Item set of 1 item. So this is how the item set are. So more than 1 item becomes an item set. So this is my item set. So if I look at this 1 and 3 here, 1 and 3, don't think this it's transaction ID. It's some products. Okay, it's like this वाला data. ये वाला data अलग है. तो इसमें items जो है 1, 3 और 4 हैं items. तो item 1, 3 इनका individual items का support, और इस तरह से product code, yeah Vipul, absolutely you can say that it's product codes, here it's actual products. तो हम इस तरह से एक टेबल बनाते हैं, जैसे कि हायरार्किकल क्लस्टरिंग में एक डेंडोग्राम बन रहा है, यहाँ पर when we are talking about we are creating tables. अब टेबल्स लेकिन आइटम सेट 2 या 3 का वो डिपेंड करता है कि आप क्या चाहते हो। आप ब्रेड, मिल्क और बटर तीनों की सेल बढ़ाना चाहते हो तो आप इस पे फोकस करोगे। आप सिर्फ मिल्क एंड बटर या ब्रेड एंड मिल्क की सेल बढ़ाना चाहते हो तो आप इस पे एनालाइज करोगे। ठीक है, एक सिंगल प्रोडक्ट की सेल के ऊपर एनालाइज करना चाहते हो तो आप इस पे करोगे, विच इज अनदर थिंग, बट वो इतना यूजफुल नहीं रहेगा सिंगल आइटम सेट, बिकॉज वहां एसोसिएशन का कॉन्सेप्ट ही खत्म हो गया। तो आइटम सेट 2, 3, 4 वाले साइज में हम इसकी बात करते हैं। ओके, एंड दिस इज नॉर्मली यूज्ड इन वेयर? सो दिस इज यूज्ड इन द फील्ड ऑफ मार्केट बास्केट एनालिसिस। लाइक मार्केट बास्केट क्या होता है? आप जो बास्केट लेके जाते हो मार्केट में और सामान लेकर आते हो, तो आपकी बास्केट में आप क्या क्या सामान भर के लाए, दैट इज मार्केट बास्केट एनालिसिस। Similarly, there are some other where you can do association rule mining, protein sequencing, for example, where you want to see a different combination of proteins, what is the association between them to come up with a new drug when you have to do drug discovery, right? Like आजकल चल रहा है कोविड का, तो protein sequencing is happening. Okay, within protein there are internal things A, T, C, G, right? Some adenosine transpose, whatever. There was some network fluctuation. Am I audible? Damini, can you make me the presenter, please, if you're there? Damini, you're there? Guys, can someone call Damini and ask her? So guys, means I think let's call it for the day, and we will continue tomorrow because anyways I have some urgent work. But I'm again reiterating, no problem. We'll do it tomorrow because anyways I have to leave somewhere. But the point is, when we talk about association rule mining, it can be used in multiple areas to just identify the correlation between the objects. So you don't have features here. You don't have features to relate to. You just have the observations in which you have the objects, and you will see कि कौन सा object किसके साथ ज़्यादातर transactions में आया है. तो अगर आप ड्रग डिस्कवरी में देखो तो आप ये देखना चाहोगे कि कौन कौन से प्रोटीन्स मोस्ट ऑफ द टाइम साथ में कंपैटिबल हैं, सो दैट जब मैं नई ड्रग डिस्कवरी करूं तो I will use those proteins which are always having more chances of being compatible with each other. And to do this, we have certain algorithms, like a priori algorithm is one of the important algorithm. Okay, a priori is the algorithm. You can read about this. So tomorrow I will talk a bit more about a priori algorithm and recommendation engines and PCA, but then we will implement the agglomerative clustering in detail tomorrow when we talk about the linkage criterias and the distance matrix associated with it and the threshold. These are the three things we will talk about tomorrow in terms of formula on the agglomerative clustering. Okay, so thanks guys, thanks a lot.
Excuse me, sir.
Yeah, tell me.
सर अभी जो लास्ट जो आपकी स्लाइड थी एक बार वो फिर से समझा दो अभी, जो आपके रीलॉगिन से पहले जो लास्ट स्लाइड थी.
So yeah, Gulzar, I can explain it, but the problem is I can't share the screen. Damini is not available right now. So that's what मैं यही कह रहा हूँ कि कल मैं ये स्क्रीन एक बार दोबारा एक्सप्लेन करूंगा a priori algorithm वाली, and then I will talk about recommendation engine and then I'll implement the hierarchical clustering. तो मैं एक बार इसको रिपीट कर दूंगा, ठीक है? और आप मीनवाइल ये पीपीटी अवेलेबल है मेरे गिटहब अकाउंट पे, आप वहां से ले लो और वहां से समझो सकते हो, एंड देन वी विल टॉक अबाउट दैट टुमारो. ओके, टेक इट फ्रॉम माय गिटहब अकाउंट.